This topic is considered as application of LCM. First we start with the concept of application of LCM. We have some standard questions here that may be asked in different exams, CAT, SSC, banking. So we are going to start it one by one. Application of LCM. The first application of LCM is on the concept of circular race. Circular race. Suppose few persons are participating in a race. A, B, C. A takes 20 seconds to take the complete round. Means if A has to complete the whole race, he takes 20 seconds. When we consider the B, he takes 25 seconds to take the whole round, and C takes 30 seconds to take the whole round. There are three persons A, B, C, and they takes 20 seconds, 25 seconds and 30 seconds to take the whole round. And now here the question is, if they start together, after how much time they meet for first time at starting point. The question is, after how much time they meet for first time at starting point. Right? When I look at this question here, two conditions are given here, first time as well as starting point. In these questions, two conditions are given to you. The first is the first point, second is the starting point and first time, right? In a question where these two conditions are given to you, in that case, we have to simply take the LCM of the time taken. Why we are taking the LCM? Suppose when we consider about A, he comes to this point after every 20 seconds, means for first time he will be there at after 20 seconds, second time 40, then 60, then 80 and so on. When I consider B, after 25 seconds, 25, 50, 75, so on. And when we talk about C, 30, 60, 90 and so on. Means if we want all the persons to meet for the first time at the starting point, we need here a common value that comes in the table of all the three. We need here a common value that comes in the table of all the three. And when I take the LCM of these three, right? 20, 25 and 30. Earlier I told you 20, 25 and 30. You have to take the LCM. Take 5, it's gone 4, 5 and 6. You can may take 2 as 2, 5 and 3. Right? Here I can say LCM is said to be 5 to 10, 10, 100 into 3, 300. So I can say LCM is said to be 300 seconds, or our answer is after 300 seconds they meet for the first time at the starting point. Now if you want to find out for the second time, third time, fourth time, just add 300 again and again. Means that is the answer after how much time they meet for the first time at the starting point. If I have to find the question for the second time, my answer becomes equal to 600 seconds. If I have to take it for third time, it is equal to 900 seconds and so on. After circular race, the second application of this concept is about, it may be about the lights or it may be about the bells. Okay. It is given that we have few lights. Light A, on it is written as L legal. Right B, it is taken as point, and light C, foundation. We have three lights. On A, it is written as legal. On B, point, and C, foundation. Right? The first light, it lights after every 10 seconds. Second, after every 20 seconds. Third, after every 25 seconds. Right? If all the three lights light together, after how much time they light again together. After how much time they light again together. Right? Now if you have to answer this question, it means we have to find a time after which they light again together, means we have to find the common time. Common time means simply LCM of the given numbers, LCM of 10, 20 and 25. When we take the LCM of 10, 20 and 25, our LCM is said to be 100. So we can say our answer is said to be 100 seconds. That becomes our answer. Okay. In this question, one more variant can be added. Suppose when we consider the light A, it is given that it flashes after every 10 seconds. Now it is further added that the light A flashes after 10 seconds for 5 seconds. Means once it flashes, the flash will remain for 5 seconds. Similarly, light B, after 20 seconds, it flashes for 5 seconds. Light C, it flashes for 10 seconds. What is given to you? There are 3 lights. The first flashes after every 10 seconds, but now it is after flashing for 10 seconds, it flashes for 5 seconds, right? It was there for 5 seconds. Similarly, light B and light C. Now the question is, if they flashes together, after how much time they again flashing together, right? The question is same, after how much time they again flashing together, but in this question one more variant have been added. The variant is, that is, it flashes for 5 seconds, for 5 seconds and for 10 seconds. Now if I have to answer this question, so what I can say, 10 seconds plus 5. Now my flashing total time is 15. Similarly, it is 25 and it is said to be 35, right? Now take the LCM of this, your answer is there. This is the question once asked in CAT exam. In this, all informations are same, but this time is also given to you. In order to answer your question, you have to add these times and then take the LCM of it. We can take the LCM of 15, 25 and 35, right? Here I want to tell you the approach that we apply, that is the factorization approach. 15 would be taken as 3 into 5, 25 is 5 square, 35 is 5 into 7. Now I have to take the LCM. LCM is taken as, take all the prime numbers, so I may take 3, 5 and 7, and power should be maximum. So maximum power of 3 is 1, 5 is 2 and 7 is 1. So I may say 3 into 25 into 7. So this would be taken as 75 into 7, or I can say 525, that becomes the answer. So we can say that if we have to find the flashing time of the lights, they will again flash together after 525 seconds. If the question is of this simple, if the question is that one, in that case just take the LCM of this time taken and your answer is this one, 100 seconds. But if one variance is added, it flashes for 5 seconds, means it flashes after 10 seconds, then it was there for 5 seconds. In that case, we have to just add this timing in that, and after that we are in a position to get our answer. Our answer is said to be 525 seconds. I hope it's clear. Similar question may be asked in the case of the bells. For example, it is given that there are 3 bells. They toll after every 10 seconds, 15 seconds and 20 seconds. There are 3 bells. They toll after every 10 seconds, 15 seconds and 20 seconds. The first question is, we have to find out if they toll together, after how much time they will toll again together. After how much time they will toll again together. Right? In order to answer this question, what I can say, 10, 15 and 20. Take the LCM of 10, 15 and 20. We can say the LCM is said to be 60 seconds. So our answer is, after every 60 seconds, they will toll together. So we can say our answer is, they will toll after 60 seconds. Sometime a question is asked here in order to create confusion. It is given that between 6 to 7, for how many times they toll together, including the starting one at 6, including the starting point at 6. Right? Now from this we infer that they toll after every 1 minute. In 6 to 7 there are 60 minutes. Generally our answer to be 60 times. But here it is given that we have to also include the starting point. Starting point means when the timing is 6 o'clock, at that time bells toll together, it means one more time is added. Here my answer is said to be in 1 hour they will toll together for 60 times. That becomes your answer. I hope the idea is clear. So what I told you now, the question is very simple. If you have to just find out after how much time they toll together, answer is 60 seconds, take the LCM, or I can say after 1 minute. But if the question is this type, a timing is stated to you and you have to find out in that timing for how many times they toll together, then in that case we can take it as 1 hour 60 times and one more time we have to include, that is the starting point. 60 plus 1, our answer is said to be 61 times. So here my answer is said to be 61 times. Then after this, we have very good problems here. These are the questions based on numbers. Right? Before starting with the concept of the numbers here, I just tell you here two things. These are very basic things that must be known to you, the students, because they are not good in that. The question is, we have two questions here that you used to solve in the class of 6th or 7th. Find the largest 4-digit number. Find the largest 4-digit number which is exactly divisible by 21. Which is exactly divisible by 21. That's the first question. The second question is, find smallest 4-digit number which is exactly divisible by 17. We will take any other number here, that is 17, right? Now what is the process to answer the question? Or this question may be asked by a different way, but first I will solve it. What do you mean by the largest 4-digit number? 9,999. You have to divide this number by 21 and find the remainder. What remainder you will get? It will go on 4. You get it as 84. Then 15 is 159. It will go on 7. 147. You get here 12. 9. 21. 6. 126. Here I can say remainder left is equal to 3. Right? It means when I take this number, largest number I have to find out, it means my largest number is either 9,999 or it is some smaller than 9,999. Here my remainder is 3. If I subtract this 3 from this number, it means in that case if I divide my number by 21, my remainder is 0. It is exactly divisible. So here what I can say, if I have to find my largest such number, my answer is said to be 9996. That's my answer. Right? Now I will look at this question by different approach. This question may be asked in such a way, what should be subtracted? What should be subtracted from largest 4-digit number, from largest 4-digit number, so that it is divisible by 21, right? What should be subtracted from the largest 4-digit number so that it is divisible by 21? So here what I can say, we have to subtract 3. If I subtract 3, I can say number becomes divisible by 21. The question may be looked now two ways. If you have to find the largest such number, divide the number, whatever the remainder you get, just subtract the remainder from the given number and your answer is there. And this question may be asked also in such a way where the question is, what should be subtracted, right? What should be subtracted? It means whatever the remainder you are getting, that remainder you have to subtract, you get such largest 4-digit number. Now the second question is, we have to find the smallest 4-digit number. So here I can say my smallest 4-digit number is 1000. I will divide this number by 17. 17 585. My remainder is 15. Take it as 0 150. Then 17 will go on 8. That is 136. Remainder left is 14. Right? Now I have to find the smallest 4-digit number. My smallest number is 1000. Means my answer should be either 1000 or it should be more than 1000. So here I cannot subtract that 14, because if I subtract 14 it becomes a 3-digit number. So in such case I have to add in this 14 I am getting it. For making it divisible by 17, I have to add here 3. If I add 3, my number will be divisible by 17. What I want to say here that in this question where I have to find a number which is greater than the given number, in that case you have to add the difference between the divisor and the remainder. So here I can say the difference between the divisor and remainder is 3. 17 minus 14, that is 3. So I have to add here 3. So I can say my answer is said to be 1003. It becomes my answer. Right? So here I can say our answer is said to be 1003. Or this question may be looked in one different way. The question is, what should be added? Question is, what should be added in smallest 4-digit number, in smallest 4-digit number, so that it is divisible by 17. It is divisible by 17. Right? So that is an introduction to this topic. Now after understanding this, I am going to start with a concept, and these 2 points I will use while solving our questions. Now here we are talking on the topic of LCM and HCF, and we are understanding the concept of application of LCM in the concept of numbers. Now I am going to start with the first statement. The first statement is, find the smallest number which is exactly divisible by 3, 4 and 5. The first question is, we have to find the smallest number which is exactly divisible by 3, 4 and 5. It means I need a number which is a multiple of 3, 4 and 5. I have to take the smallest number. I take the LCM. That LCM is said to be 3, 4, 5 LCM is said to be 60. So I can say smallest such number is equal to 60. Second question is, find the smallest number which when divided by 3, 4 and 5, it always leaves remainder 1 in each case. Now I change my question. What my question is, when I divide my given number by 3, 4, 5 and it leaves remainder 1 in each case, that means my smallest number is 60 and every time remainder is 1. So I can say my number is said to be 60 plus 1. That smallest number is said to be 61. That smallest number is said to be 61. You may check here now. When you divide 61 by 3, you get your remainder to be 1. When you divide by 4 or 5, every time you get your remainder to be 1. Third statement is, find the smallest number when divided by 3, 4, 5. When divided by 3, 4, 5 respectively, 3, 4, 5, it leaves remainder 1, 2, 3 respectively. What the question is, we have to find the smallest number, the number which when divided by 3, 4, 5, it leaves remainder 1, 2, 3 respectively. Okay. Now it's a very special question. In this, these are my respective divisors and these are my respective remainders. It simply states me that when you divide the number by 3, the remainder left must be equal to 1. When you divide your number by 4, it must be 2. Divided by 5, it must be equal to 3. Okay. Now here I can say the difference between divisor and remainder is 2. Here also it is 2. Here also it is 2. Okay. Now if the difference between divisor and remainder is same, in that case, if you have to find such smallest possible number, the concept is very simple. Take the LCM of 3, 4, 5. So we can say LCM of 3, 4, 5 is said to be 3, 4, 5 LCM is said to be 60. Right, and whatever the difference we are getting, that is 2, that is same in all the cases, subtract 2 here and you will get your answer to be equal to 58. What the question talks about? The question is, find the smallest number which when divided by 3, 4, 5, it leaves remainder 1, 2, 3 respectively. So what I can say here, I will just take the difference. 3 minus 1 I am getting 2, 4 minus 2 I am getting 2, 5 minus 3 I am getting 2. So I can say in all the cases the difference is equal to 2. What I can say now, I just take the LCM of this, that is 60, and subtract the difference 2. 60 minus 2, my answer is said to be 58. That becomes my answer. Okay. So these I started with the 3 basic questions. Now in these questions, I just found the smallest number. Sometime he may ask you, you have to find smallest, he may ask you find out second such smallest number. Second smallest number. Right? Now when I look at this question, my smallest number is 60. For finding the second smallest number, I have to again add 60. Why? Because I have to add the LCM of 3, 4, 5, that is 60. My second smallest number is now equal to 120. Here if I have to find the second smallest number, my first smallest number is 61. I add again 60 in that and I get my number to be 121. Over here I can say my number can be generalized as 60x plus 1. My number can be generalized as 60x plus 1. If I have to find my smallest number, I start with putting x to be 1, that is 60 plus 1, 61. If I have to take the second smallest number, 60 to 120 plus 1, I may get it as 121. Or I can say every time you have to add 60 in that and you will get the consequent numbers. Similarly for this question, here my general number is said to be 60x minus 2. Here my general number is said to be 60x minus 2. If I put x equal to 1, I may get 60 minus 2, that is 58. If I put x equal to 2, 120 minus 2, my answer is equal to 118. Or I have to add 60 in this, my answer is said to be 118. I hope got the idea. Similarly, it may further be changed and the question is now, find such smallest 4-digit number. Question is, you have to find such smallest 4-digit number. Okay. Now we know that smallest 4-digit number is 1000. Smallest 4-digit number is 1000. In the first case, we have to find the smallest 4-digit number which is exactly divisible by 60. So we will divide 1000 by 60 and we have to find a number which is divisible by 60. So here I can say when you divide 1000 by 60, your remainder is 40. Earlier I told you, take the difference, that is 20, that you have to add. Your answer is said to be 1020. Okay. Similarly for the second case, my number formation is 60x plus 1. In the first case I found it to be 1020. Here my answer becomes 1021. Similarly here, my number formation is 60x minus 2 and I have to solve it. So what I will try, I just try to multiply to be 1020. I have to subtract 2. My answer is said to be 1018. That's my answer. I hope got the idea. So this is an introduction to this in the case of numbers. Now when we further extend it, I started with a question where the difference is same. You may find some questions where the difference is not same. In that case, we try to find out what approach we have to show so that we are in a position to get our answer. The fourth type that we may take, it is given that find a smallest number which leaves remainder 7 when divided by 11. When number is divided by 11, the remainder left is 7, right? And when divided by 12, when divided by 13, remainder left is 12. Question is, we have to find the smallest number. Number when divided by 11, it leaves remainder 7. When divided by 13, the remainder is 12. We have to find such smallest number, right? Now in this question, when we look at this question, the difference between divisor and remainder is not same. Here this is 11 minus 7, the difference is 4. Here 13 minus 12, difference is equal to 1. So we can say the difference between divisor and remainder is not same. Where the difference is not same, in these questions, what approach we have to apply? We have to apply the generalized approach. You have to divide your number by 13, remainder is 12. Your general number could be taken as 13x plus 12. When you are dividing your number by 13 and remainder is 12, so you may say your number is said to be 13x plus 12. Now you have to divide this number by 11 and remainder left that you require, that must be equal to 7. Okay. Now we have to start to put the values of x 1, 2, 3, 4, but that is a cumbersome process. For that we may try one more approach here. From 13x, take that portion which is exactly divisible by 11, that is 11x. Similarly for 12, this is 11. Now what is left? Here it is left 2x, here it is left 1. Okay, you have to divide it by 11. What I have done here, although we may answer this question by putting the values of x starting from 1, 2, 3, 4 and then check out where you get your remainder to be equal to 7. But this approach seems to be cumbersome, or we can say that seems to be very long approach. Till that, in order to solve it easily or smarter way, what we can apply, we just break these two numbers into the multiples of 11. That portion I have taken separate, and I am being left with 2x plus 1. I have to divide it by 11. Now we can say that this portion is always divisible by 11, whatever value of x is there. And now from when this 2x plus 1 is divided by 11, I need the remainder to be 7. That could be got when we put x equal to 3. Because when we put x equal to 3, we get it as 6 plus 1, 7. So I can say the remainder is said to be 7. Now based over this, I put 3 here. That is 39 plus 12. Right? So I will take it as 39 plus 12. This is said to be 41. Sorry, this is said to be 51. Now you may check out. When 51 is divided by 11, it will go on 444, remainder is 7. When 51 is divided by 13, the remainder is equal to 12. Okay. So that is the smallest number that satisfies both conditions. My smallest number of this type is said to be 51. Now here also, if I have to write a general number, because question may be of any case, he may find the second smallest number, or he may also ask you, find a number which is largest 2-digit number, 3-digit number, it may be of any type. For that, first of all, you have to find the smallest number by this approach. Then take the LCM of this 11 and 13, because my divisors are 11 and 13. When we take the LCM of 11 and 13, we get it as 143. So I may write my general number to be 143x plus 51. So I may write my general number to be 143x plus 51. Right? Now you have to find the second smallest number, put x equal to 1, and you get it as 143 plus 51. This is said to be 4, 9 and 1. My answer is said to be 194. Similarly, if I have to find the second smallest number, put x equal to 2 and just add. Or if I have to find a largest 3-digit number or 4-digit number, first find the close multiple of 143 and then add 11 in that, your answer will be there. Now after this, we have one more question in order to understand the concept. What this question talks about? It is given that we have to find a smallest number. We have to find a smallest number when divided by 12, 16 or 18. Every time it leaves remainder 1. Every time it leaves remainder 1. When we divide the number by 12, 16 or 18, my remainders are equal to 1. And when we divide the number by 17, but when we divide the number by 17, remainder left is equal to 0. Remainder left is equal to 0. Right? We have to find such smallest number possible. Now this question contains two things. The first one is we have to find a number which when divided by 12, 16 or 18, the remainder left is 1. It means I just take the LCM of 12, 16 and 18 and remainder left is 1. So I may find the smallest number, that is LCM of 12, 16 and 18. Right? Here I can say my LCM is said to be 144. LCM is said to be 144 and I have to add 1 8. So I can say my smallest number satisfying my first condition is 145. Right? But here I have to also add the second condition here. For adding the second condition, the number must be divisible by 17. For that, first of all, we have to write the general number. So your general number would be written as, earlier I told you, but you can make it as 144x plus 1. Your general number would be taken as 144x plus 1. Means when you divide this number by 12, your remainder is 1. Divided by 16, it is 1. Divided by 18, it is 1. Now the question is, when this number is divided by 17, remainder left is equal to 0. So what I require, what I need it as 144x plus 1 divided by 17, remainder must be equal to 0. Again we will apply that same approach. Earlier I told you, first you may start with by putting 1 to 3, but that is a lengthy approach. For that, what is the smallest approach? You have to break this 144 into the multiples of 17. And here I can say 17 is that is said to be 136. So I may break it as 136x, right? And here what is left now? We are being left with 8x plus 1, and that is divisible by 17. Now we have to simply check out, because 136x is always divisible by 17, and I am being left with 8x plus 1, that has to be divided by 17. Now when I put x equal to 2, you may get it as 16 plus 1, 17, and I need my remainder to be 0. So I can say that when in the given statement, when you put x equal to 2, you get a number which is exactly divisible by 17. Put here x equal to 2, you get it as 288 plus 1, 289. So that is your answer. So we can say this is the smallest number which when divided by 12, 16 or 18, every time it leaves remainder 1. When this number is divided by 17, your remainder left is equal to 0. That becomes your answer. All these questions are based on the concept of application of LCM. Now after the concept of application of LCM, the next point that I am going to discuss, this is the application of HCF. This is the concept of application of HCF, that is highest common factor. Okay. Now earlier as I told you, HCF is highest common factor, and factor is always smaller than the given numbers. So in that we have some varieties of question. So I am going to start with some varieties of question. The first question is, find the largest number which divides 1920, 640 and 1320 exactly. The question is, we have to find the largest number which divides 1920, 640 and 1320 exactly. When I look at this question, I have to find a number which divides this number exactly, means I have to find the factor of these numbers, and that is the largest. It means I have to find the highest common factor, that is the first application of HCF. Now for finding out the HCF, from where I can start with it? Why I take two pairs? I prefer to take these two pairs. This is 1920 and divide this number by 1320. You may also go for the prime factorization approach that earlier I told you. Here I will start with 1. It will take given as 1320. Remainder is 600. Then here you have 1320. It goes on 2. You get 1200. Remainder is 120. It is 600. It will go on 5. It is 600. That is cancelled out. So I can say 120 is the HCF of these two numbers, 1320 and 1920. Now one more number is given, that is 640. Now we will find the HCF of 640 with this 120. Apply the same process. It goes on 5. You get it as 600. 40 is the remainder. Right here 120. It goes on 3. 120. That is also cancelled out. So here I can say my final HCF is 40. So we can say 40 is such largest number which divides this given number exactly. What the question talks about? Suppose I have three numbers, 1920, 640 and 1320, and I have to find the largest number that divides these three numbers exactly. So from where we can start, we just take this pair, right? Go by step by step. My quotient, here the divisor is 120, or I can say HCF is 120. Then take this 120 and divide it, and here finally you can say that is said to be 40. Right? This is the first application of HCF. Second question is, this is a very important question. What this question talks about, it is given that in a school there are boys and girls. Boys and girls. there are 289 boys, and 340 girls, right? It is given that these girls have to be divided in different sections such that each section contains equal number of students, each section has equal number of students, and secondly, each section have either boys or girls. Each section has either boys or girls. Either boys or girls. Right? Two such cases have been given to you. First case is each section must have equal number of students, and the second is each section will have either boys or girls. We have to find out what is the minimum number of sections that are required. The question is, we have to find out what is the minimum number of sections that are required. Okay. Now, from where I will start, this keyword is there. Minimum number of sections are required in order to accommodate the boys and girls. If nothing is given, if it simply gives you have to find the total number of sections. Your answer is cannot be determined. Why? Because no condition is given how many students are there in a section. For that, something must be there. Here use the term minimum. It means if we have to find number of sections to be minimum. So what I can say, number of students in a section have to be maximum. Number of students in a section have to be maximum. Right? Now if number of students have to be maximum, it means we have to take a number that the highest number that divides these two numbers exactly. And here my two numbers are 289 and 340. Means first of all I have to take the HCF of 289 and 340. Right? By looking at the question I can say HCF is said to be 17. HCF is said to be 17 because when I make the prime factorization I may take it as 17 square and there I may take it as 17 into 20. Highest common factor is prime factor is 17. So I can say HCF is 17. It means number of students in a section must be 17. And the question is I have to find the total number of sections. I have to find total number of sections. If we have to find the total number of sections, so we have to divide the sections for boys and section for girls. 289 boys are there. Number of sections required 289 by 17. For girls 340 by 17. This is said to be 17 plus 20, right? And my answer is said to be 37. 37 is the total number of sections required for accommodating the students. I hope the idea is clear. The same question may be asked in a different way. He may state you that you have two varieties of milk, or may say you have two different carriers of the milk, different buckets. First bucket contains 289 liter, second contains 340 liter, right? You have to measure the milk. The question is, and the statements are given that maximum measurement have to be used. What could be the total number of measurements in order to measure it? So we may take the HCF that is said to be 17. For measuring it 17 times or measuring it 20 times, so I may say 37 times are the minimum requirements so that the whole milk can be measured. Now the second application of this concept of HCF is, it's a very important question also. You have one piece of cloth is given. One piece of cloth is given, whose length is 20 feet and the breadth is 14 feet. Question is, one rectangular piece of cloth is given, length is 20 feet and breadth is 14 feet. The whole piece of cloth have to be cut in small equal squares. so that no piece get wasted. No piece of cloth get wasted. Right. Question is, here we have two type of questions here. The first question asks from you, what is the maximum number of squares that you can make, square pieces that you can cut out of it? And the second one is, what is the minimum number of square pieces that you can cut out of it? We have two type of questions here. The first is, what is the maximum number of pieces that you can cut out of it? The second one is, what is the minimum number of squares that you can take out of it? Now, in order to answer the question, because the condition is given that no piece of cloth get wasted, and we have to cut into the different squares. First, I try to find the maximum number of squares. Now, just think of, sometimes the student may commit mistake. They take for getting the maximum squares, they take the side to be 1, but that's not, because he is concerned with the maximum number of squares. The side has to be smaller, as minute as possible. He has nowhere stated us that the side must be integer, so I may take side to be very small, right? Here I can say maximum number of squares are said to be infinite. Why it is infinite? Because the square can be as small as possible. There is no condition is given that the side of the square must be integer. In that case, we can say the maximum number of squares are equal to infinite. The second question is, we have to answer minimum number of squares. For taking the minimum number of squares, side of the square must be maximum, right? And it is a condition given in the question that no piece of cloth get wasted. When no piece of cloth get wasted, it means side of a square means such a number that divides this and this exactly, right? It means I need the HCF of 20 and 14. By looking at the question, I can say highest common factor of 20 and 14 is 2, right? It means my square must be there whose side is 2. Okay, now we have two different approaches in order to answer it. For finding the number of squares, first approach is take the total area, that is 20 into 14, divide by the square area, 2 into 2. You get it as 10 into 7. My number of squares are said to be 70. That is the first approach. Or secondly, you may say this total length is 20 divided by 2, you get 10. Similarly, it is 14 divided by 2, you may get 7. 10 into 7, total number of squares are said to be 70. It becomes your answer. I hope the idea is clear. So this talks about application of HCF. About how to divide in different squares so that no piece of cloth get wasted, as well as the minimum number of squares we have to find. After this, we have few more questions. The next statement is, find the largest number. Find the largest number which leaves remainder 2 and 3, which leaves remainder 2 and 3 when divided by 89, and when it divides 89 and 148. When it divides 89 and 148, the remainders left are 2 and 3. We have to find such largest number. Now the question is, when it divides 89, the remainder left is 2. It means when I subtract 2 from here, I get 87. 87 is exactly divisible by the given number. Similarly here, 148, here my remainder is 3, I subtract 3, I get it as 145. Means the question is, find the largest number which divides these two numbers exactly. Means I have to find the highest common factor, right? Now take the HCF of 87 and 145. When you take the HCF, we have different approaches. The first is, we may apply prime factorization. 87 is said to be 29 into 3, right? And 145 is said to be, 29 into 5. Now if I have to find the HCF, my answer is said to be 29, and answer to this question is 29 is the largest number. When we divide by 29 these two numbers, you get your remainders as 2 and 3. The answer is said to be 29. Last, not the least, question that we are discussing in the concept of HCF, application of HCF is, it's also a very important question. In number of exams you will find these type of questions. What is given that find the largest number. Find the largest number. Question is, find the largest number which divides 444, which divides 444, 804 and 1344, leaving same remainder in each case. Leaving same remainder in each case. Right. Now he has not given us the remainders. He has simply given us from each case the remainder left is same. Now if you have to answer this question, what approach I can apply? I can simply apply it as, take it as the difference in pairs. 804 minus 444. One pair is there. Second one is 1344 minus 804. And third pair is 1344 minus 444. Right? It's a very standard question, because if I have to find a largest number by which when these three numbers are divided and every time it leaves the same remainder, we take the difference in pairs. Here I will get it as 0, 10, 4, 6 and 7, 4, 3. Right? Here you may get it as 0, 4, 13 minus 8, 5. Here you may get it as 0, 0, 13 minus 4, 9. Right? Now take the HCF of these three numbers, highest common factor. Right? Here when I look at this question, so I may say highest common factor is said to be 180. Because 180 is a number that is dividing these three numbers exactly, and no more number than 180 can divide these three numbers exactly. So we can say HCF is said to be 180, or earlier I told you the methods by which you can find the HCF to be 180. Now we try to verify. First number is 444. When you divide it by 180, it will go on to 360. In that case, the remainder left is equal to 84. Right? The second is 540. First is 444, second is 804. When you divide this number by 180, right? You may say it will go on 4. 18 4 is 720. And in that case, my remainder left is 84. Right? Similarly, third number is 1344, and when you divide this 1344 by 180, it may go on 18 7 is 1260, and in that case the remainder left is 84. Means in all these three cases remainder left is same. Means the given condition is satisfied, which states that in each case remainder is same, and we have to find such largest number possible. So I can say that such largest number is said to be 180, and how we find such largest number, that may be found by taking the difference in pairs and then take the HCF of those numbers. Your answer will be there. Okay, so this is the concept of LCM and HCF. In this topic we understood what is the process to find LCM and HCF, as well as different properties of LCM and HCF, and finally we understood about the different applications of LCM and HCF.